Hey, Mr. Allred here, and I got one last method of factoring to talk about, and it's called factor by grouping. And it's a little hard to explain in words without an example, but basically we're going to take something and group certain terms together. And if we have a common factor out of those two groups, then factor by grouping will apply. So let me kind of work through this example I have here. It's 5x cubed plus 15x squared plus 3x squared plus 9. Now I know you're looking at this and you see those middle terms and you want to add them together, and maybe you can get somewhere with that. But let me kind of handle it the way factor by grouping would. And sometimes it doesn't matter how you group, but I'm going to make a group out of the first two terms, 5x cubed plus 15x squared, and the second two terms, which is 3x squared plus 9. And if I look at those, I'll notice that in the first one, the 5x cubed plus 15x squared, I can pull out a 5x squared. If I pull that out, I'll be left with x plus 3. And then when I look at the second group, 3x squared plus 9x, I realize I can pull out a 3x. And if I do that, I'll have an x plus 3 left. So now I went from 4 terms added together to 2 terms added together, because there's a product in the first part and the product in the second part. But those two, the first one has 5x squared times x plus 3. And the second one is 3x times x plus 3. So now I've arranged it in two big terms that have a common factor. So I can pull that common factor out front. I can pull the x plus 3 out front since it's in both of those terms. And what will be left will be what's being multiplied there. 5x squared from the first one plus 3x from the second one. Okay? And so you can actually see the x plus 3 out front. Now, I didn't notice it when I wrote this problem, but one other thing we could do is in the latter part here, the 5x squared plus 3x, I could actually pull an x out of that. So I can make it x times x plus 3 times 5x plus 3. And then it would be factored completely. So if you've done a different method, you might get the same thing there. Okay, another example. This one you might have a hard time figuring out alternate ways to do it. But this one is 40x plus 3x squared plus 4x cubed plus 30. Now, these things can be a little tricky, but just because you see things written down, you don't have to group them the way they are presented to you. So I'm going to rearrange some things. I'm going to put the 40x and make it plus 4x cubed. And then I'm going to take the other two terms plus 3x squared plus 30. Okay? And I'm going to group them in that order. They don't have to be groups of 2, but that's what we're working with here. So 40x plus 4x cubed. I can pull a 4x out of there, and I'll be left with 10 plus x squared. Now the second set, 3x squared plus 30, I can pull a 3 out of there, and I will have x squared plus 10 remaining. So I could rearrange some things there, but what we see is we have a 10 plus x squared and x squared plus 10, which are the same thing in two different terms. So I can pull that 10 plus x squared, or call it x squared plus 10 out front, and that would be times the remaining parts of their factors, which are 4x plus 3. So just to make sure you see where that came from, I'll highlight it. And if you ever wanted to try and get back to the original and check your work, you could FOIL this thing out or use a distributed property and see where it goes. Alright, there you go, factor by grouping. It's kind of hard to spot sometimes, but can be pretty useful if you've got the right amount of terms. Just because you have 4 terms doesn't mean it's going to work though.